So welcome to 6.6. So we're going to be solving using the elimination method. Again, this is day 2 of this. And yesterday we added or subtracted equations to eliminate x or y, and that happened automatically. But that doesn't always happen so easily. Mr. Ben wrote those so it would happen so easily. Today we're going to take it to the next level. So let's remind us what we did yesterday. Right? We looked to see if we had opposite terms or the same amount, and here we have opposites. So when we have opposites, we're going to add them together, right? We have 2y, positive 2y and negative 2y. We're adding them together. We're writing that we're adding them together. 3x plus 4x is 7x. 2y plus negative 2y is 0. 18 plus negative 4 is 14. Divide both sides by 7. X equals 2. So that's the x coordinate of where they intersect. I'm going to put it in the top one. I could put it in either, and I get this. So I get 3 times 2 is 6. So I'm going to subtract 6 from both sides. 2y equals 12. Divide by 2, and y equals 6. So these two lines intersect at 2, 6. 2, 6 right there. All right. So how do we use elimination method where there aren't terms that are the same or opposite, right? We have a 3 and a 6 here. Well, adding them together won't eliminate x. Subtracting them won't eliminate x. We have y and negative 4y. Adding those together won't eliminate y or subtracting them. So what do? Well, right, what if we manipulate the equations, right? We have these rules that as long as you do things to both sides, the equation will remain true. So what if I took that top equation maybe and multiplied it by 2? Now why did I decide that? Well, look what happens. I get 6x plus 2y equals 13 times 2, 26, right? And then I'm rewriting the bottom one. Now, could I do something? Yeah, now I could subtract, right? I turned that 3 into a 6, but we have rules, right? The rules say if you do something like that, you got to do it to both entire sides. It's not the only thing I could have done. What else could I have done? Does anyone have any ideas? Well, how about if we multiply the top one by 4? Well, what would it be then? It would be 12x plus 4y. 4 times 13, 26, 52, yeah. And then we have 6x, the bottom one. I'm going to leave us. Oh, look at that. Now I could add them together, right? Because we have opposites, right? So you're going to have to look at them and make a decision. There is going to be more than one way to do most of them. Either way would create an elimination. All right, so when there aren't terms that are the same or opposite, multiply both sides of one of the equations to create terms that can be eliminated. So make a choice here. Well, I think the most obvious is to multiply everything here by 2. Top one stays the same, 2x plus 3y equals 15. The bottom then becomes 2x plus 8y equals 20. Now I can subtract them because I have terms that are the same. 2x minus 2x is 0. 3y minus 8y, negative 5y. 15 minus 20, negative 5. Divide both sides by negative 5, y equals 1. So where these lines intersect is at a y coordinate of 1. I can put that 1 into either one. I'm going to put it in the top, right? I'm going to subtract 3 from both sides. 2x equals 12, and x equals 6. So they intersect at 6, 1. Right. Let's try another one. All right. What are our choices here? Well, we could multiply the top one by 3. Hopefully we see that. What else could we do? We could also multiply the top one by 2. Let's do that, just because be different. So the top equation becomes 2x minus 4y equals 2. The bottom one stays exactly the same. What did we do by multiplying both? We created opposites in our y's. So now we can add. Always write whether you're adding or subtracting. 2x plus 3x equals 5x. Negative 4y plus 4y is 0. 2 plus 23 is 25. Divide by 5. x equals 5. We can put that, I'm going to put it in the bottom. 3 times 5 plus 4y equals 23. Well, 3 times 5 is 15, so we're subtracting 15 from both sides. 4y, 23 minus 15, I believe, is 8. Divide by 4, and y equal 2. So they intersected at 5, 2. Now, you have to decide today what type of strategies do you prefer. So there are people who always want to add, and you can always add and never subtract as long as you multiply things by a negative when you need to. Okay, you can have that strategy. Or you can be more flexible and sometimes add and sometimes subtract and sometimes deal with y and sometimes deal with x. There's usually a faster or slower way, but multiplying everything by 3 here, all right, would have been totally reasonable. All right, if you did it that way, you will get the correct answer, but you will eliminate x first. You'll get the 2 first and the 5 second. All right, so let's see here. This one's pretty obvious what you do. Yeah, this one, I think there's really only one good choice, and that's multiplying the top one by 3. Because then you get 12x minus 3y equals 12. The bottom one stays the same. We're going to add them together. We get 15x plus 0 equals, 30. That turned out very nice. And x equaled 2. All right, we put the 2 where the x is. 3 times 2 is 6, so we're subtracting 6 from both sides. 18 minus 6 is 12. Y equals 4. These intersect at 2, 4. Okay, so, right, could you multiply the equations first, then rearrange them to line them up? Yeah, you could, but I don't recommend that, right? We need to get these lined up. So I'm going to always put them in standard form. To do that, I'm going to add 2x to both sides. And so this one becomes 2x plus, whoops, I'm making a mistake there, 2x plus 3y, right, equals 15. And the bottom one is negative 6x plus 2y equals negative 12. Okay, so now that I've done that, I'm looking at them, and what am I going to do? Well, I'm going to multiply the top one by 3 is what I'm going to do. So there's a lot of writing here. 3 times 2x is 6x plus 9y. 3 times 15 is 45. Leaving the bottom one the same as it was right at the beginning. And by the way, you could write it right underneath there. You can switch the bottom one and make it the top and the top one the bottom. Totally allowed. Right? And so we're going to add those together. Notice I'm going to write this nice big plus sign because you want to make sure that you realize that negative 6x goes with that and that you're adding them together. So 9y plus 2y is 11y. 45 plus negative 12, I believe, is 33. Divide by 11, y equals 3. So there's our y coordinate is 3. We're going to put it in, I'm going to put it in the bottom one, negative 6x plus 2 times 3 equals negative 12. Subtract 6 from both sides. Negative 6x equals negative 18. Divide by negative 6, and x is also 3. They cross at 3, 3. Okay. Again, I need to rearrange if I'm going to line things up here. So I'm going to add 2y to both sides here and make that one 2. Oh gosh, I'm almost violated what I said. I was going to not make it in standard form, but standard form would be x plus 2y equals 4. All right, so I have 4x minus 3y equals negative 17. So I really don't have much choice here. I'm going to multiply the bottom one by 4. All right, so we have 4x minus 3y equals negative 17. That's the top one. The bottom one now is 4x plus 8y equals 16. All right, so I'm going to be subtracting these, and this one's tricky. All right, I'd like you to pause and try it, because this is where mistakes can happen. 4x minus 4x is 0. Negative 3y minus 8y, what's that? That's negative 11y, right? Negative 3 minus 8. Same as negative 3 plus negative 8. Negative 17 minus 16. That's negative 33, right? Same as minus 16, same as adding negative 16. Divide both sides by a negative 11. Y equals 3. All right, I'm going to put, we have a nice equation on the bottom with x all by itself, ready to go to find x. X is -2 times 3, -6, plus 4 is -2, and so these cross at -2, +3. So we're rearranging them first, getting them all lined up, then we're deciding whether we should multiply by. So let's look at this. Oh my goodness, all right? So, right, top one is not in standard form, although x and y are on the same side because fractions are not allowed. But let's clear the fractions, right? How do you clear fractions? You multiply everything by the same number, and that crosses out, and we get x minus 12y equals 4. Oh, well that worked out because look what happened there. Let me just fix that little, right? The bottom one is -x plus 8y equals 0. So I can add these two equations together. I don't have to multiply them by anything else. It just happened that way. Mr. Ben wrote it, so all you had to do was clear the fractions. X plus -x is 0, or the opposite of x. -12 plus 8y, -4y. 4 plus 0, 4. Divide both sides by -4. Y is -1. Okay, so then we have negative, I'm going to put it in the bottom to avoid the fraction. -x plus 8 times -1 equals 0. So that's -x minus 8 equals 0. We're adding 8 to both sides. There's a lot of ways to mess up the sign here. -1x equals 8. Divide by -1. X equals -8. So it's -8, -1 is the point of intersection. I have a feeling that maybe this one's going to have fractions in the answer. Let's see. So you have two choices, right? We can multiply the top one by 3 or the top one by 2. Either will work. I'll go with the top one as by 3. So that, let's write it out. Take our time. Minus 6y. 3 times 0 is 0. Interesting. 3x plus 4y equals -2. So I'm going to be subtracting. 3x minus 3x is 0. -6y minus 4y, -10y. Oh my goodness, I'm going to get a fraction. 0 minus -2 is 0 plus 2 is 2. Divide both sides by -10. And y is -2/10, also known as -1/5. Okay, so we can put that into the top equation. X minus 2 times -1/5 equals 0. -2 times -1/5 is 2/5, right? Right? -2 over 1 times -1/5 is 2/5 and equals 0. Subtract 2/5 from both sides. Oh, all right, that wasn't so hard. I thought it was going to be harder than it is. Right? -2/5, -1/5 is the point of intersection, right? These are all coming nice out in whole numbers or integers, positive and negative whole numbers, because we're writing, Mr. Ben is writing them that way because we're learning how to do it. But it can absolutely have decimals and fractions in your coordinates. All right, let's practice. Whoops, I guess the one on the right has fraction coordinates. I am going to multiply the top one by 3 here. So, and I'm going to show you that you can switch them. So I'm going to intentionally do that. So I'm going to put -15x. I'm just going to write that down here. So -15x plus 6y equals 36. Now I don't think this is necessarily going to make it easier, but it makes it less writing. Okay, and some people, students, hate writing. So now I've got opposites, so I'm going to add them together. 2x plus -15x is -13x. Is that right? Yes, and this is 0, and 3 plus 36 is 39. Oh, this is going to work out nicely. Okay, because 39 divided by -13 is -3. So the x is -3. I'm going to put it in the top. And so that's +15. So I'm subtracting 15 from both sides. All right, is that right? So, and -3, all right, and then we get 2y equals -3, divide by 2, and y equals -3/2, or -1.5. All right, that makes me nervous, hopefully. So we could double check it. Let's look at the I'm going to put it in the bottom equation and see if that still happens. So 2 times negative 3 is negative 6. Minus 6 times negative 3 halves. Okay, so that's negative 6. I'm checking my work here by putting it in the bottom equation. Cancel, and that becomes 3. Negative 3 times negative 3 is positive 9. Yeah, negative 6 plus 9 equals 3. That is the combination. So there was a fraction in the y coordinate. All right, the next one needs rearranging. So I'm going to rearrange it as x minus 4y equals negative 1. And then we have 2x plus 2y equals 3. Well, I'm going to multiply the top one by 2. You absolutely could have multiplied the bottom one by 2. Either way works. The top one by 2 is 2x minus, let's write it out. Don't be lazy. Minus 8y equals negative 2. And I'm going to be subtracting the bottom one, which stays the same. You get 0, negative 8 minus 2y, negative 10y. Be careful. Negative 2 minus 3, negative 5. Okay, negative 2 minus 3 is negative 5. Divide both sides by negative 10. Negative 5 divided by negative 10 is positive 5/10. Simplifies to 1/2. All right, so we have a 1/2 for y. Then we're going to put it in the bottom. Oh, that's not so bad because those cancel and become 1. 2x plus 1 equals 3. Subtract 1 from both sides. 2x equals 2. Divide by 2. And x equals 1. So now it says to use elimination. You don't worry about graphing it. I'll graph it. And so I'm going to rearrange it and get the top one. Right, I'm going to make that add 2y to both sides. X plus 2y equals 6. Then we have 2x plus 4y equals negative 4. All right, so then I'm going to multiply the top one by 2. And I get 2x plus 4y equals 12. All right, so I'm going to subtract the two equations. I just wrote that underneath. I told you you're allowed to do that. 2x minus 2x is 0. 4y up, we get 0. Negative 4 minus 12, negative 16, but it doesn't really matter. We get nonsense. What does that mean? It means they have no solution. And what does that mean about the lines? Are they the same or parallel? Which one is no solution? No solution means they never intersect. So these are parallel. These were parallel lines. There's the top one. I just want to make sure that is the top one. There's the bottom one. And they were parallel. All right, so we're going to replace the question mark with a number to create a system with infinite solutions. So they have to be, to have infinite solutions, they have to be the same line twice. Ooh, this is tricky. All right, so this one is in standard form. So let's, we're going to look at this. This is tricky because, all right, so let's subtract question mark y from both sides. Subtract question mark y from both sides. All right, so now we have on the bottom x plus 3y equals 9. On the top we have x minus question mark y equals 3. So what does the question mark have to be? The question mark has to be negative 3. Yeah, it does, because otherwise they won't be the exact same line. The only way you get infinite solutions is if you have the exact same line twice. Boom. Good luck with the homework.